Well, hello, welcome everyone to our first ever virtual home tour series. Real quick, if you're having any sound or audio issues, head up to that audio tab. Click on the sound check up there. That usually resolves most of your issues. And if that doesn't work, try switching between phone or computer call-in. If that doesn't work, log out of GoTo, log back in. You may lose a sound during the session, so just remember to do that. For those of you looking for your continuing education, watch the entire session, and then a survey will come up at the end. Make sure to take that survey. The same survey will be sent to you an hour later. So just take either the one that pops up or the one that's sent to you. And even if you don't need CEUs, we certainly appreciate all your feedback. So let us know how you feel about the session. Support our mission, get instant access to all of these events without having to register, along with discounts on other events and trainings that we're doing. Go to greenhomeinstitute.org, become a member today. And yeah, let's get moving here. Real excited to be announcing this first virtual home tour, low carbon design with a budget in mind. And your CEUs for this course are traditional ones: GVCI, AIBD, BPI, non-whole house. We're still pending AIA, health, welfare, and safety, so we'll get that out, and that may make it applicable to your state-based design or contractor license. My name is Brett Little, and I am the executive director at the nonprofit, the Green Home Institute. And today, again, just the focus of this session is how do we get to low carbon homes with budgets and making sure we do it in an affordable, cost-effective way. And before we jump into it, I want to say a huge thanks to our top tier sponsor, Mitsubishi Electric. They can help you get to net zero, all electric homes, single family, multifamily, new and existing, ducted, ductless, and VRF systems that can simultaneously heat and cool spaces, heat and cool buildings, and ventilate them all at the same time. Check them out at mitsubishicomfort.com. And then also our second tier sponsor, Ava Window, with high performance R7 windows, as well as all aluminum windows with recycled content. All right, well, welcome to, again, low carbon design with a budget in mind. We have two speakers today. Our member, Nate Kipnis, we're excited to have him back again. Last time we were out with him was doing a live tour when it was safe to do that in person on the scene. So we're real excited to have him back out for this. Nate is the designer of today's home. He's one of the most respected national authorities on resilient, sustainable residential and commercial design, practicing the architecture philosophy of high design, low carbon. Long before it was in vogue, he is the immediate past national chair of the AIA's 2030 Commitment Working Group and is a member of the AIA's National Sustainability Leadership Group. Recognized as Chicago's premier award-winning sustainable architectural practice, Kipnis Architecture and Planning, founded in 1993, has offices both in Evanston, Illinois, and Boulder, Colorado. Kipnis also is the founder of the Next House Alliance, a unique team of premier design and building firms committed to incorporating sustainability and resilient designs into their residential projects. And then we also have Scott Sanders, Brightleaf Homes, president. And as a home building executive with an interest in sustainable practice in both business and his personal life, he has found that his strength in facilitating getting things done by bridging the gap between the ideal plans and the shifting reality of rapidly changing situations in projects, business, and climates. So we're excited both to have Nate and Scott. And Nate, I'm going to kick it over to you. Please take us away. Thank you.
Thanks, Brett. Yeah, good to be doing another one of these. This is a little unusual. I'm sitting here in my office. So this is a project that is challenging because there's a definite budget. And this is a project in Evanston. It's relatively close to my office here. This is a young couple. It's their first home. And it's kind of crazy to think that a starter home is basically $1 million. I mean, you know, with it all said and done, I'm not talking the exact budget here, but it's a difficult task to do a house. And when there's a budget like this, there's always going to be some compromises or some tricky decisions that have to be made. And that was definitely the case in this situation. So again, this was a young couple, and they actually got married during the project, which honestly, if they can make it through this project then and get married, they're in for a very happy and long relationship and marriage. So what you're looking at here is the house when we modeled it. And just to point it out, there's a yoga room, a kind of a meditation room in the front. And that's this white clad gridded elements. And then the same element got kind of thrown into the back and rotated, and that's the garage. This was a tricky site. I'm going to go over that in some detail as well. And let's see. So before I get into the specifics of the house, this is just showing kind of the range of stuff that we do. These are almost all of these are all electric. And so that's where we've been going with our projects. The two that are kind of interest right now, the bottom right one is an all electric home that we're just starting in Boulder, up in the mountains of Boulder, Colorado. And the one right above it is an eco retreat. I can't give the exact location, but it's in the United Kingdom. And just really amazing. So that's going to be net zero, all electric, really great. And so this is really the trend that we've been involved with for quite a while. And this was a challenge with this house because it's not necessarily parity to do all electric. There are some additional costs, and I'm going to also talk about that. This is just a great quote I want to start with before I get going. It's from Hunter Lovins, who I had as a professor at University of Colorado in Boulder back in 1982, with Amory Lovins. So in a stable economy, sustainability is the competitive advantage strategy. In a down economy, sustainability is the turnaround strategy. In a collapse, sustainability is a survival strategy. So it's really a good thing to have a sustainable home and a healthy and resilient home that can handle these things. This is the site, and it's the one that says, it's down by the lower left. My office is towards the middle, so it's like a 10 or 11, 12 block little bike ride over there. It's nice to do that, and as you saw, we do buildings and projects all over the place, but it's really great to have one this close. So I think we're going to try and take a look at the project site, and I'm going to send this over to Scott. We'll see if that works.
I think I'm coming across. We'll see. We have some challenge on remote. I know you can hear me audio-wise. Not sure if we can see video-wise yet, but I hope so. We're standing in front of the project right now in Evanston. And the perspective we tried to get set up for the one that Nate had in his screen as he was sharing it with you. You can see right now we're using a zip wall system from Huber, and Nate's going to talk a little bit about the trade-offs between this system and the typical system that he designs in the homes that he builds or designs, I guess. And then you can see also that we've got contractors working today. So we've got both siders and roofers working on the project. So once we go inside and walk through the home inside a little bit, it might be a little bit noisy. Please bear with us. We've had some rain over the past couple of days here in Chicago, and so we want to get some stuff done, and Saturday morning is a good time to do it. So I'm going to kick it back to Nate to talk a little bit more about the site logistics and layout and location of this property while we walk inside and get set up inside with video.
All right, thanks.
Nate, go back to you.
Yeah, hey, this is like a broadcast booth here. It's kind of fun throwing it back here. So here's the site, and it's a corner lot. It's adjacent to the river, and it's adjacent to a park. And so we had some challenges on this site. The zoning code in Evanston is written or had been changed in the last couple of years so that the front yard setback is the average of the adjacent homes on either side. Well, when you look at this, there's nothing to the east, and to the west, because of the way the park kind of clips into the sites, there's these two houses that are set way far back. So we had to go through a zoning ordinance review, a zoning variance review, which was, at the end of the day, you know what the answer is, but you need to do it. And it's unfortunate that the site was set up that way, but we ended up getting that to work out. And then this is the, I'm sorry, you can see the screen, right, Brett? So yeah. Here's the actual site plan. And some things we had to deal with, and I think we actually, as a compromise, we actually moved the building up. The required setback is about 5'4" on the west side. I think we ended up moving it 4 or 5 feet further, maybe 3 or 4 or 5 feet as kind of a compromise. And then the other thing was the garage isn't supposed to be more forward to the street of the house. So that was a zoning variance, because if the garage went back here, there's like no private area for a yard. So again, just looking at this, here's the front of the house. To the left, we've got that yoga studio, meditation room, and then the main house. And then going out the back is a deck. And then there's a bit of a yard in between the corner of the lot and the garage. So they have 2 yards, but it's always tricky having a yard on the exposed side of a corner lot like that. This is the first floor plan. And basically, this is not too dissimilar to a Chicago floor plan. Chicago has typically 25-foot wide lot, and you have the utility core on one side. And so in this case, we have stairs, the powder room, mud room, and then you have the main space. And then there's a family room on the back that's a couple steps down, and that leads out to an open deck that's yet another step down. The interesting thing here that we always try and do on a first floor is to provide the ability of a powder room to convert to a full bath. So you see next to the powder room, to the right of it, it says future tub. And in the meantime, it's a broom closet or coat closet. So that's the size of a tub. And if they needed to, for some reason, make, maybe the den would become a bedroom or something, sometimes, or the family room, so sometimes we do that where there's a bedroom available on that main floor, and then the ability to have a larger than just a powder room there. I'm going to switch back, and we'll be able to see where we're currently at on the first floor.
Indeed we are. All right, so we're back here inside now on the first floor. You can see that the home we have under construction, we're already in drywall. So there's not a lot of cool behind the walls stuff to show. But we are gonna take a quick walk through the home when Nate kicks it back to us after we go upstairs. And then we'll also do the Q&A from inside the home. So we can walk through the first floor, go down into the basement, go back up to the second floor. But what Nate was mentioning, that you said that's right, was the wall of windows that comes across over here in this direction. And this is a really awesome feature that Nate and his team were able to put together, of just this full wall of windows in both directions. Also, Nate's next picture that he's going to show is of the stairway going up, and he's talked a little bit about the wall system that we have. That's a great picture from during construction that we were able to take, and Nate was able to cut into the presentation. So I'll leave that back to Nate, and then we'll get set up upstairs.
All right, thanks. Just to covered porch area. This covered porch area, and you see this dotted line, that's where that kind of the meditation room mass kind of lines up. So the ceiling in this area under the den, the ceiling of the den and the covered porch will also be gridded. When we go to the second floor, there's 2 bedrooms. One of them's the master. The master has its own bathroom with 2 sinks and then a walk-in closet. There's a hall bath, and then this meditation room with quite a high ceiling. I think it's about 14.5 feet high. That could be walled off. It's set up to be the 3rd bedroom up there. So you would just extend the end wall of the bathroom down and then close off part of the stairwell. So it's a really nice floor plan, flexible in that respect. And then in the lower level, in the basement, there's a stairwell going down to a den, and the mechanical room, which has a lot of stuff in it. All of our projects tend to have a lot of stuff in it. When you're doing electric, we're pre-wired for battery backup, and they are going to actually put in a battery that'll be interconnected to the solar panels. There's room for the furnace, the ejector pump, and sump and water heater. And then there's a laundry and a bedroom, and like I said, the bathroom, and then there's storage back there. Moving on to, Okay, so here's the main crux of this project is we were really trying to make this all electric. And the reason we do that is because, you know, that's the way to decarbonize a building. Okay, if you want to get rid of fossil fuels and get rid of CO2, that's how you do it. And you go to the grid, and the grid is not perfect, but it is every day getting more and more renewable energy on it. And we want to be able to utilize that. And so being all electric is really the goal with that. ComEd has this program where they give a $2,000 incentive, and I would encourage anyone looking for doing an electric home to definitely contact ComEd about this. The $2,000 helps you offset some of these costs. So as you can see the list here, it might be kind of hard to see, but it's all electric space heating, water heating, and clothes drying. An air tightness of under 2.5 air changes per hour. We're going to be under 1. And then an air source heat pump or a ground source heat pump, LED lighting, et cetera, et cetera. So these are the things we do on all of our projects. So this sounded great, but there are some tricky aspects to this. And one of them is there's a good chance you're going to have to go from a 200 amp to a 400 amp. So there's a cost involved with that. Not always, but if you're doing, it depends on the size of the house. You know, as you're getting it larger, to do heating with either a ground source or air source heat pump is going to require a lot of electricity. So there's some other costs involved, you know, to get the air tightness and to get the other all electric components, a little bit more money. It's getting more affordable all the time. But that $2,000 is intended to help with that. It is likely not going to cover all of it. And at the end of the day, the owner decided not to do it. And that was a tricky thing. I think they're still going to have an absolutely amazing house, but this is the battle when you are watching the budget. And so this was a starter home, and it's not, you know, every dollar counts, and I get it. It's a challenge to do this, and you have to make some tough decisions. Like I said, it's still going to be an amazing house, so I'm not really worried about it. But the goal would be, as the costs continue to come down over time, I think this will get easier and easier to do. When we do an all-electric home, this is what's involved with it. So it's an induction cooktop, which they are going to have, which is a great move anyway. And especially on a tight house, because a gas cooktop is going to be putting out CO2, and why would you want to do that? Plus, a lot of the top chefs are using induction cooking. It's safer, it's quicker. There's so many good reasons to do it. And then we have an air source hybrid water heater that we've been using now for a number of years, and same with the dryer. And so the next part that is typical is the heating system. We like air source heat pumps. Ground source is another one that typically is all electric. This is a schematic of showing an air source system, and you can see the outdoor unit. And I would also point out on these outdoor units, do not mount them on the ground. They're not air conditioning condensers. These are for heating. So when there's a huge snow, that can be a problem. I know in Boston, they had a gigantic snowstorm. It was 6 or so years ago, right when people started putting in air source heat pumps, and they ended up having a bunch of them mounted on the ground, and they were buried under snow, and they didn't work. So we will raise them up to take that into account. And then, of course, you want a smart thermostat, which this house is going to have. Some of them have geofencing, and what geofencing is, is the ability that it knows where your cell phone is, and as you go outside that range, you'll be able to have the system shut down, and when you come back, it'll come right back up. So really a nice way to do that. And then this is the idealized wall system that we would typically use on a house like this, where we have 2 inches of rigid insulation on the outside, and you can see that in the image here on the left. And then we have an air barrier behind it, and then furring strips. On the right, you're seeing the furring strips, and then we've got siding. In this particular example, which is not what we're doing with this house, we are using boral siding, which is a waste fly ash siding. So that's an embodied carbon strategy as well. We're not using that. We're using cement fiberboard, which is also a good move here. And then so we ended up using this Mooney wall system. So this is an unusual system. If we're not doing rigid insulation on the outside, we want to have a lot of insulation on the inside. So we got a 2x6 wall. And then if you just did 2x6s and you put in cellulose, you've got the potential for a thermal bypass. You've got bridging on the edges of the 2x6s. So the Mooney wall puts a 2x2 perpendicular to that. So you've got really small contact area. It's this little red area right here that you can see in the diagram on the right. It's really a small area. And now we've got an extra 1.5 inches of insulation. So instead of 5.5 inches of cellulose, we've got 7 inches. So between those two things, this was really a good way to do it. If we couldn't do the rigid on the outside, which is definitely a cost, to be able to do this system really, really worked out well. I'm going to throw it back over to Scott, and we'll do that right now.
There you go, Scott. Oh, you may be self-muted. Guys, you may be
I am not self-muted.
There we go.
All right. Thank you for muting me before. So we're standing up here on the second floor now in the yoga meditation room that Nate was talking about when we first started to come inside. You can see just from the general openness of this room, there's no lights on in this home right now. And that's one of the things that I love about the design that Nate has put together here. Is even down in the basement, if we do go down there during one of the Q&As, you're going to see how much natural light there is coming into those spaces where you literally can be throughout this entire home without needing to turn on a light for the majority of the day. And so as energy efficient as we can make homes, and for as many LED light bulbs that we put in and advanced systems to save energy, ultimately if we don't have to turn on a light bulb, it doesn't matter how energy efficient it is, it's using zero energy. So that is fantastic here. I do want to show one of the details in reality that Nate was talking about the Mooney wall system. We have obviously all the drywalls you can't see, but this is exactly what Nate's talking about, is sort of the 2x2 strip on the outside of the regular 2x6 wall assembly. So behind the drywall that we have here, of course, is a 2x6 framed wall with that 2x strapping. The reason that you see this strapping going vertically is because it's around the window assembly, and so we need some place ultimately to nail trim to. The walls actually got dense packed cellulose insulation in it, which you couldn't see in the picture that Nate showed. And that dense packed cellulose insulation has additional air sealing going on. And Nate's actually going to talk for a second about the air barrier system that we have here, Aero Barrier, which we piloted and tested out on this particular home to make sure we could hit the ACH number that we were looking for. While Nate's talking about that, we're going to jump back downstairs and get reset up to go through the end of Nate's presentation and be ready to answer any questions that are pertinent to what's going on site.
All right, well, I grabbed the screen back, and so here's that Mooney wall again, and I want to show you what it looked like when the insulation went in. So it's interesting to see this. Normally, when you see insulation put in like that, you have vertical members, but because this has those horizontal strapping in members in there, you see it this way, which is really, really neat. And again, very little contact points, very little thermal bridging going on here. This is an unusual system. Dan Contreras in my office tracked that down, and I really like it. I think it's something we'll definitely keep in our arsenal of good thoughts. And as Scott was mentioning about the daylighting, we like to start with as many passive things as possible, and that includes natural daylighting and natural ventilation. So we've got some skylights on remotes that open up that allow for really nice airflow, especially if you open some low basement windows, you just get some really great air movement through the house. I want to go over some of the statistics for this specific design. As I mentioned, we have a 7-inch cellulose wall, which is a R25. In the basement, we have 1 inch of EPS foam on the exterior and 3.5 inches of rock wool batts, and that adds up to an R20. We have a 2-inch EPS foam under the slab and a 16-inch net and blow cellulose roof insulation. That's an R56. We ended up using Sierra Pacific windows, their H3 unit here. So this is an argon low E, which is what we typically always do. This happens to be double glazed. This is, you know, I think the next move up is triple glazing. It's still very expensive, but the price is starting to come down. We're starting to see that. And I think in the future, you're going to see in this climate, you know, on anything that's high performance at all, it's going to be triple glazed. And I think that's going to start filtering down into standard practice as well. So those windows have an R3.57, but of course the low E makes them perform even better. We also had the windows set up with the solar heat gain coefficient depending on the orientation of the windows. And sometimes that number, 0.2 or 0.28, is even a bigger difference depending on the orientation. As Scott mentioned about the aero barrier, and I'm going to put a slide up on that in a minute, we're going to end up with a ACH 50 of under 1, and that's going to be really impressive. There's an air-to-air heat exchanger as well as part of this. The energy use intensity is 22,000 BTUs per square foot per year per the 2030 commitment, which I've been involved with for a very long time. There's a 3.72 kilowatt solar array on the garage with a battery backup. I think it's a 24 kilowatt battery backup system. There's room on the regular roof for another multiple of that, if not more, and there's room for more battery backup. So as prices become more available, we'll see if they want to do that. It's already pre-wired up to that secondary roof, so it's easy to do that. The PV array currently produces about a little over 25% of the annual energy use. And again, if we double that, we'll be over 50%. The garage is wired for EV charging as well. So here's the aero barrier sheet. And Scott, I don't know if you want to jump in on this. I'm not sure if you can see it or not, but this is the report that they provided. And I know the way that they do this is it's kind of like a taxi meter. I mean, they just keep going until you tell them to stop. And they have the blower door test going live in real time, and you can see exactly the impact. You know, every 5 minutes you start to see a little change. So this is reporting a 67% reduction in that envelope tightness or leakage, I should say.
Absolutely, Nate. So this is done in the field. You can do aero barrier. If anyone on the call is familiar with aero seal, which is generally done to seal ductwork from the inside, both in new construction homes and existing homes to meet duct tightness requirements. This is sort of the next generation of that put out. So this will help seal an entire home. How this sort of works is there are very small particulates that are generated. I can't say if they're latex or not. Jeff Farrell's probably going to be yelling at me from aero barrier for not knowing this. But the overall idea is that the home is pressurized, and this aerosolized product is injected essentially into the home. And as the home is pressurized, the air is trying to find its way out of the home. And so these particulates wind up going to those locations where the cracks in the exterior sheathing are, or where there might be a gap at a framing plate or something, and coagulating on themselves, thereby sealing up that hole. And the awesome thing about the air barrier system is that you can literally dial in the air tightness that you're looking for, as Nate was mentioning, because it's a blower door test in essence, but just pressurizing instead of depressurizing the home. So you can go anywhere from 5 ACH to 3 ACH to 1 ACH to 0 ACH if you want to run the test long enough and put enough of the material going through the home. We chose to do this aero barrier sealing during the frame construction. Oftentimes it was also done after drywall is complete, but before the home is completely done. So this is a test home for us at Brightleaf to understand how the aero barrier system works and to understand what is an appropriate time to do it during construction. I will say that this home, as you can see from the outside where Nate was showing, has a flat roof assembly. And so this is not a vented roof assembly, which the majority of other Brightleaf homes are. And so it makes it very difficult to do an air barrier system when you have a gabled or a conventionally framed roof, which is vented, because there's no way to seal off the lid of the home and distribute the air barrier product throughout the rest of the home overall. So this was an awesome project to test it off on as a flat roof construction that we were able to do before drywall went up. And as Nate said, dial in that 1 ACH prior to drywall. So hopefully after we hit drywall, we'll be down, as Nate said, below 1 ACH. And that'll be tested and verified at the end of construction, of course, by a HERS rater using a conventional blower door system and setup. Nate, to you.
Yeah, so you can see on the screen that chart, and it's going for 170 minutes or so and just tightening it up as it goes. And it's an amazing concept. I really like this. This is the first time we've used it, you know, that you guys set that up, and it's just great to see it. So let's keep going. This is showing the energy analysis. So this is where we see the difference between going with an all electric versus not. And again, you know, tough choices when we do houses all the time. I mean, even when people have a big budget, they have a budget, and it's not easy to get everything you want in. So we do this energy testing to kind of see where we're at. The first line is, let's see, what do we got here? So this is with no PV and with the forced air natural gas. So it's got an EUI of 29. When we put in with the PV, we drop it down to 22. If we do a mini split system, but no PV, we're at 24. And if we do the mini split with the PV, we're at 16. So the decrease is quite significant. It's going from 29 in the worst case down to 16. So this house is 22, 23, something like that. I think 22 is what we ended up at. This is, you know, I think this is going to become more and more doable as the cost of the mini splits drop, as the cost of the PV drops. This is kind of the goal, because the one highlighted in blue at the bottom is the all electric with the PV. You know, this is kind of the ultimate goal. So it's really good to see this. And then I'm not going to go into detail, but when we use Sapphira for our energy analysis, there's lots of good energy modeling programs, but you can see the energy split here on the right. And it is helpful. I will tell you, one of the interesting things is, as everything's getting more and more efficient, we're getting the heating load reduced, we're getting the cooling load, the refrigeration, the lighting. The thing that is not moving very much is the plug loads. And that's a whole nother discussion, but I just want to put that out there, that the plug loads being like computers and everything you plug into the walls that aren't the appliances, that, you know, and that's the AV system, the home security systems. Those things have not been getting more efficient very quickly. So that's a target that everyone is sort of focused on at this point. I'm going to kind of go through a few images. This is what the house will look like in context. This is the view from the middle of the side street. And then we've got the front view and kind of the corner view that I believe we started with the presentation at. And again, that box over the front door is the meditation room, and that gridded perimeter is what goes under the underside of it, which becomes the ceiling of the porch and the interior. And then this is some aerial views on the right. This is with the PV panels on the garage, and then the future PV panels up on the main roof. You can see the operable skylights over the family room, and then the porch, the deck off the back. There's a couple windows into the bedroom, I'm sorry, into the basement level that are window wells. And then this is the interior. So on the left is the family room with the skylights, and then the view from the front looking towards the back. I'm going to run some animations here. This is the exterior of the home. The stair tower is clad in, I believe that is a cement fiberboard that looks like stone. So another good use of that. This is showing it without the PV panels on the main building, but on the garage, they are being shown. And then this is an animation going all the way through. So this is walking into the house, and you can see that ceiling with the grid. And then you're in the dining room, kitchen, and then looking towards the family room. So really excited about this. We're really excited about where we're at with the project. It's been really good working with Brightleaf. I really like using Buildertrend, by the way, just some online system to be able to show us what's going on, because we can't get out to the site very easily right now. And that's been really, really helpful. So with that, Scott, if there's anything you want to go over, we can talk about it. Or we can start looking at some questions.
Absolutely, yeah, Nate. Let me just talk for just 1 minute about the overall project and Buildertrend in general. Again, I apologize for the guys that are working outside, so if you're all hearing some hammering and some air compressors back there. But Nate was mentioning the overall project schedule and Buildertrend here. This project is live, so we're here today. This is continuing on during COVID and during the quarantine. Because we're able to use WorkSafe practices on site. Troy, our marketing director, is the only person here in the building with me right now. The guys outside are working safely. We've had to stage construction a little bit differently during the process here, but the system that we use to be able to communicate with clients, and so Nate can keep track of the project overall, is Buildertrend, and we are doing daily logs from the site every single day for what's happening and what's going on. So that's been really handy to have overall as a tool to keep both our clients and Nate as our architectural partner informed here and to keep the project moving quickly. Also, technology has been awesome. We're doing things like video calls with the clients, things like video calls with our project managers on site to solve problems along the way. And yay for technology, I guess. There couldn't be a better time to try and put some of this stuff into practice. I will say one more thing is that we're downstairs here on the first floor. Back on the first floor, and where we'll stage for the Q&A session. Overall, this home is extremely energy efficient. Nate talked a great deal and had some good insights about the trade-offs that we had going on here for overall cost for the home versus some of the things that we wanted or needed to put in. And we're definitely aligned with Nate and with ComEd overall in their energy efficiency program about trying to move towards all electric. Brightleaf actually recently built a research and development project in Forest Park called Flipside Forest Park, where we have a series of 3 townhomes in 3 different stages of construction, or 3 different heating and cooling, I guess, and overall energy power sources. So the first project there at that townhouse is a conventional, for us, natural gas forced air furnace system that is powered with natural gas and electric for the air conditioning. The second townhouse there is partially run on an air source heat pump that is distributed through the home with a conventional ducted system by Mitsubishi, which we're extremely excited about testing out. And then the third home of that 3-unit townhouse row is another Mitsubishi system, but it's a hybrid system where we have a ducted heating and cooling system for the first and second floor, and some wall-mounted cassettes down in the basement to serve as an in-law arrangement. So we're excited about testing out projects like that to be able to see the difference side by side, as we have the same exterior envelope, the same glazing pounds in general. So we'll literally have side-by-side data to be able to use and honestly to prove to architect partners and clients and everyone else the benefits or the trade-offs from going natural gas and electric combined to an all-electric home overall. So that's all I've got to say here. I'll turn it back over to you, Nate and Brett.
Yeah, thanks. Before I forget, I just want to say it again. The clients were fantastic. You know, they were very enthusiastic, just absolutely perfect to work with. They bike rode over most of the time. I mean, just really, really great. Really looking forward to them getting in here. And yeah, as far as like, you know, going all electric, we've been, you know, we've been doing that, and we've drank the Kool-Aid. We love it. We think this is definitely the way to go. And we always use Mitsubishi because of the low temperature range that it can get down to. So, you know, when you're looking at these systems, that's something to really be careful about. We're in a tricky climate, and there's a lot of good options on their systems to handle the cold. That is the one thing that has just kind of recently been evolved with the mini splits. In the past, they only went down to, you know, originally it was 40 degrees, then 13, then 5, and they finally got it so it goes way down into the cold temperature ranges. Yeah, Brett, do you have any questions that we could talk about?
Yeah, hey everybody, we do have some questions, and before we get to those questions, just real quick, for those of you who want to get your continuing ed, remember to take that survey that pops up at the end. The same survey will get emailed to you as well, just take it once. We appreciate that, and for those of you taking this on demand in the future, take that quiz with an 80% passing rate in order to get your Con Ed. In order to find that quiz, go ahead and click on our YouTube link at the bottom, and then on the left there, you can see, click the Show More tab to get more details, and then on the right there, you'll see head down to access the quiz, that link, and fill out the information. And again, before we get to those questions as we're coming in, just a huge thanks to our board of directors, our volunteers, all of our members, and our top tier sponsors, Mitsubishi Electric, for getting to net zero. All electric homes, multifamily commercial buildings, as well as Rheem Air Source, the Prestige Air Source heat pump for all electric water heating. That's super efficient. And our top tier sponsor, Build Equinox, as well, for a smart ventilation system in your home. So yeah, there were quite a bit of questions that came in on the interior aero sealant process and product. And a lot of them, of course, revolved around cost. So, you know, without obviously just saying, here is the cost, which, you know, just, you know, maybe put it into the context of, you know, labor saved, which I think is one of the benefits versus the ability to air seal. And, you know, if you want to share any general information on cost too, that's helpful. But I know that there are those trade-offs.
There are, and I can definitely talk a little bit about that. For us, again, this is a pilot project for us. This is the first time that Brightleaf has used the air barrier system from that manufacturer. And so we're honestly trying to understand the full cost trade-off, Brett, as you were talking about. We normally have an extremely airtight envelope already for all of the homes that Brightleaf builds, not taking into account the air barrier system. Using exterior zip wall or blue skin in some cases, or just using tieback properly installed and detailed, we can get down and have gotten down as a company under 1 ACH conventionally, I guess I would say. So the air barrier system here was a cost study for us to understand how much less detail we would have to have for interior manual air sealing, either with caulk or spray foam, versus just letting the air barrier system go forward. So it's not that I don't, well, it is honestly that I don't know the cost because I don't have the full details on it yet as to what it was or what we would have saved alternatively. But I can say that the air barrier system made it easier to get this particular home because of the configuration with the combination of the flat roofs, the gable roofs, and the intersecting planes to be properly air sealed. This would have been a very, very difficult home to conventionally air seal with exterior detailing through the zip wall system and then interior spray foam, caulk, and sealant as well. So air barrier system, definitely a good fit for this home. We'll see if it's a good fit for the remainder of the homes that Brightleaf builds.
So one of the things about, you know, when you watch the videos of these guys sealing houses to, you know, sub 1 air change per hour, it's intense. And not that you shouldn't do that, but that this then does it in that 170 minutes. It's not going to do everything that you still have to do those things. Absolutely, you still have to do them. But this thing really goes and finds the spots that aren't sealed. And I think that's a really good thing. It is going to be interesting to see the cost analysis of this. I don't know the exact cost of this particular install. I mean, it's in the low thousands, right? Or who knows?
Yeah. Yes, Nate, correct. We're not talking $10,000, but we're also not talking $500.
Right.
The system is extensive. It is essentially an entire blower door test with a custom equipment setup. that is made to be able to aerosolize this product and inject it into the home. So yeah, it is not extremely expensive. We'll come up with the cost data, and I'm sure Brett and or Nate, we can share that at a later point as a side-by-side comparison.
I think I mentioned it was kind of like a taxi meter, and so like you can just tell the guy we're done, and it costs, you know, every minute you go, it's more money. So you can just look at the results and go, that's good for me. We can turn it off now. You know, I'm sure there's X amount to just set it up, but then there's an amount per minute of it running. The other thing I would point out, two things I forgot to mention. One is we don't do double hung windows. So these are casements and awnings because they seal really tight. I mean, to me, that's a kind of a no-brainer. And the other thing is, I don't think we talked about the certifications that this house is going to go for. So it's going to be the Net Zero Energy Ready and Energy Star and the EPA Indoor Air Quality. Scott, if you want to talk more about that?
Yep, that is correct. So at the very base level, every home that Brightleaf builds is Energy Star certified. For us, that's the ticket of entry. We're also full 100% participants in the DOE's Zero Energy Ready Home program. So as a custom and a semi-custom home builder, we're keenly aware of the fact that not everyone can afford a passive home. Not everyone can afford an extremely high level of design and construction. There's certainly a sliding scale with finding a home that is able to be attainable for many people, but still extremely energy efficient, cost effective to build, also of course weaves its way into that. So at the base level, all of our homes are zero energy ready homes, not necessarily zero energy homes, because some of our clients don't want to or can't afford the full solar install system to be able to get their home down to net zero. But the Zero Energy Ready program and certification that comes along ensures that every single home that we build is capable of having that in the future if it's elected to be done. So that means making sure that there's conduit going up to the roof or out to the garage in a case like this project where we are in Evanston, that makes sure that we have low plug loads, that makes sure that we have energy efficient lighting, that makes sure that we have a lot of base load reduction things going on in terms of the exterior wall assembly or glazing. Also, I don't want to say that the Zero Energy Ready certification is completely dedicated to just energy efficiency and performance. That Zero Energy Ready certification and the Energy Star certification, frankly, go towards building durability and indoor air quality as well. And those are two big things for us that sort of rides alongside the EPA's Indoor Air Plus program, is the Zero Energy Ready certification checklist. The third-party inspections that are done for that are on exterior durability details as well. Window flashing, foundation flashing, under slabs, since we have basements here, water protection systems throughout the basement. All of these things are covered in those certifications. And similar to LEED, except it's not based on a point system, it's based on a qualitative and performance metric that we are having an extra inspector come through outside of the village required code inspector to do inspections 2 to 3 times throughout the entire home building process. And make sure that we are delivering on the high level of quality and high level of performance to pair up with Nate's high level of design. So it's an all around well-rounded package. And it's certified by somebody other than us, just saying, hey, we build awesome homes, and hey, Nate designs awesome homes.
You know, something else before we get to the next set of questions is, you know, with everything going on, this house is set up for a good home office, either in the basement or in upstairs in that extra bedroom. It's all, and isn't that an important thing now, to have a really functional, well-designed home office space? And then also having a mudroom, having the ability to bring stuff in, having some storage space associated with that. There's a lot of things that all of a sudden are coming into much more focus, and maybe the people on the webinar here are, you know about that, but the general public isn't so clued into it. We've got really good indoor air quality. It just becomes so important about how well your home performs in times like this. So this is a really good example of that.
I'm glad you brought that up. Can you speak to a little bit about and if the Indoor Air Plus program ties into this, but now we're starting to recognize the more importance of you know, even better filtration, maybe even HEPA filtration, to stop viral spread, as well as ventilation, as well as potentially humidity control. How is that maybe in this house or just in general going to be in your design and builds moving forward?
Yeah, so I saw something that like an N95 mask, and I'm not going to remember the exact statistics, but I think it was like 95% of particles that were 3 micron were filtered with that, and a MERV 13 did 99 point something percent. The problem is that coronavirus is 1 micron, but it gets caught unless the air is just like blowing like a hurricane through there. If it's just going at a normal speed, it'll catch it. But it's just, you know, it's just such a strange time, like when you have to think about things like that. But, you know, the air-to-air heat exchanger and the filtration system, it just gives you good peace of mind being in your house. You can imagine if you have a home that doesn't have these things, doesn't have a good home office, doesn't have filtration, doesn't have good storage, battery backup. I mean, this is the other thing. Everyone's hoarding food and throwing it in their freezer. The worst thing that could possibly happen now is the power go out and have people freak out about that. So knowing that you've got all that covered is such a good thing. And I know that down the line, the codes are going to change. This is one of the things we talk about at the National AIA and there's these committees now on COVID-19 that I see the reports on. They're going to be probably mandating lever handles, door handles, and lever faucets and touch sensor things. There's a lot of thought that's going into this. You know, it's not necessarily a great thing to have a countertop that's got 200 tile pieces with all those joints in it. You want perfectly smooth countertops. Maybe even the sink is one piece because of that. So there's a whole different lens to look through to think about that. Scott, I don't know if you have anything else on the EPA system.
Sure, I can literally talk for just a few seconds about it. Brightleaf is pretty darn good at indoor air quality, but we want to get better overall. And it's amazing how quickly these things evolve. The tighter that we make our homes, the more potential for poor indoor air quality there is, obviously. It's not like my mom's home where I grew up, where literally you can just feel the draft coming straight through a wall or around a window and you get natural air changes per hour. Here we do have to make sure that it's mechanically focused, but also that it's timed properly, where we're not bringing in 0 degrees, 0 humidity outdoor air in the middle of the winter, and we're not bringing in 100-degree, 100% humidity outdoor air in the summer, or if we are, we're treating it properly and appropriately. So that is part of also our research and development, is trying to understand reactive indoor air quality monitoring systems. So maybe we can just circulate air and filter air instead of introduce outside air if we don't need fresh air, literally, if we just need fresher air inside. And also to Nate's point at the beginning of the presentation regarding induction cooking. Induction cooking obviously doesn't eliminate cooking particulate, because you get that actually from the pan and from frying or cooking the things that are in the pan, but it certainly eliminates the basically having a campfire inside your home, which is the stove or the furnace. So there's a lot of stuff that we need to get better at overall as an industry when it comes to indoor air quality, and Brightleaf is working to make sure that we're better at building it with the homes that we do to comply not only with the indoor air quality certifications, but just keeping ahead of the curve overall. It's a tough thing to figure out how to solve fully, because you solve one problem in one location and then it potentially creates another problem in another area. Yeah,
so, and also, you know, Brett, I think you were kind of hinting at the humidity issue. You know, one of the things we all wrestle with is the first year of a home is there's humidity coming out of the concrete. So, you know, that's a short term, all things considered, a relatively short term thing. But generally speaking, this is, you know, night and day compared to like a old Chicago or old, just in general, basement that doesn't have a vapor barrier under the slab, that doesn't have drain tile, that has potentially, a brick foundation that's letting water in. The goal of this is to be bone dry, and that the air quality is as good anywhere in any of the levels of the house. And that's a really, really important thing. You know, we spend 90% of our time indoors, and I think that's gone up quite a bit in the last 2 months. I think we're 99% or something. And it makes it so obvious how important that indoor air quality is.
I do want to tag one more thing on the end of this, Brett, before you go to the next question, and that's related to the budget overall for this project. So again, it goes back to, we could put in a MERV 80 air filtration system if such a thing existed. But one, that system would be more expensive than a MERV 8 or MERV 13 system that we have going in. But also the equipment need to be able to push air through that filter also is a consideration when it comes down to power usage overall. So furnaces got more efficient, but unfortunately in some ways they started to use more power because the blowers had to work harder to push air through even a MERV 8 or a MERV 13. And as air filtration gets more advanced or finer, mechanical systems have to work harder potentially. Therefore, obviously, they're using more electricity. So again, that's what I was talking about. There's a trade-off here, a benefit here, and we've all got to sort of balance those out in pre-construction, like Nate was able to do and show on the graph where he was looking at the overall energy analysis for this project. And that's where the tweaking comes in of taking one thing away and adding one thing and seeing the overall impact.
Yeah. So keeping on the talk of air quality here, there was a question about, what are you using for, hitting your ventilation requirements? We talked a lot about filtration, but what's the ventilation strategy?
That is an air-to-air heat exchanger.
Oh.
So
ERV.
Yeah.
Correct. Yep. Ducted into the system here. It'll be centrally ducted throughout the home. There's not an individual ducted system for the ERV.
Okay. But okay. Great. Yeah, that's what I thought it was. I just wanted to make sure it was an ERV.
Yeah, whenever you get something that's got an air change even remotely this close, you really have to be bringing in outside air in a controlled method. And a while ago, we used to use a product called an air cycler, which was kind of the low-cost version. But as we get these homes tighter and tighter, you really need something that is frankly, your only good option is an ERV, an air-to-air heat exchanger. So that's what's in here.
Mm-hmm. We are at our time, but we can stick around. There's a lot more questions. Are you two able to stick around, or do either of you have to get going?
Sure, I'm good.
I've got an extra 10 minutes or so. I think that'll be okay. Yeah, Troy, you okay with that?
All right, so let's hop back into the walls here and get into the Mooney system. And there's a lot of questions about just relative comparison, either whether it's just on cost or performance or ease of install. Let's think of it that way. And obviously just your general comparisons to, why not SIPs, why not ICFs? And maybe I'll chuck another one in there. And what about, considering structurally insulated framing systems or, pre-insulated studs? Can you speak to that a little bit in those trade-offs?
I'm not sure what the added cost was. Scott, I wonder if you have any notion of that. I think it's a fairly good system. And I don't think it's that expensive, that much more. I don't know, we've looked into other systems over the years, and I'm just not a big fan of ICFs, and maybe that's just me, but it was a real struggle when we looked at them 10 years ago, and I know in Chicago it was a big hoop to jump through. We have not revisited that. We've looked at prefab stuff, and I swear every time we look at it, it's hard to beat stick framing. I mean, and maybe I'm wrong. Scott, do you have thoughts on the cost of that?
I don't have thoughts on the cost right now, but Nate, I can tell you that it was incremental. This is actually a test home for us as well. This is the first time we've framed a home with this wall system. And the normal homes that we frame are actually a staggered stud wall assembly where we have a 2x6 plate with 2x4 staggered inside and out. And so this particular home, I think, was a really cool approach to try with the horizontal strapping across. The incremental framing labor necessary was fairly minimal. The thermal bridging reduction was probably significant from a conventionally framed wall. And it was nice to get that extra 1.5 inches of insulation in the wall assembly. So our added cost here, I don't have now, but it could probably be pretty easily calculated just by the 2x2 strapping that went across and by the extra framing hours, which again is something that we're working to digest for not only this project, but all of our projects is what is the cost benefit trade-off and what wall system would we recommend to be building attainable homes, more attainable homes. Same thing on the flip side Forest Park project. We had a conventionally stick framed townhouse, and then we actually had 2 off-site panelized townhomes. We didn't do SIPs there. They were conventionally framed open wall panels, but really we are interested in crunching that data and really understanding how to build the best home possible within the budget that we have, back to the point of this webinar.
Yeah, hey, Brett, it'd be great to do a webinar on that, on comparing the costs of the different systems and the performance, because I think I have a good intuitive thought on that, but I would rather actually see real numbers.
Sure.
So,
And it's subjective, you know, by day and project and whether pandemics occur or not, but yeah.
you know, so this house, like Scott was saying, it's an attainable house. It's really, you run into a lot of cost benefit issues or challenges, and you try and figure out what's the best thing to do. And, you know, when you do really expensive homes, you open up a lot more options. We do affordable housing too, and that just narrows it down. You get very focused very quick. But this is at this price point where there are some options and you want to see what the cost benefit is. I just thought that this Mooney wall, the reason we went with it, it just seemed like, again, intuitively, that this was pretty cost effective for what it was doing, gaining the 1.5 inches of insulation and knocking out all those, you know, the thermal bridging really was attractive. So you know, this was our first try at this one. I really like it.
So yeah, speaking of cost, just in general, the question here is coming in around $300 per square foot. How do you convince prospective clients to go green?
Well, when they call me, they know what they're getting with our firm, so it's not too hard to talk them into it, unless they called the wrong number. But we do, you know, this is always the trick. I mean, we can't do homes without thinking of the budget. And so in my mind, it's like, how do you prioritize things? Look, do you want a wine cellar, or do you want solar panels, or do you want battery backup, or do you want a home entertainment thing, or do you want them all? You know, it's just like, what is your budget and what do you want to do? And the other thing is one of the key things is giving flexibility. So when we started this project, we were not sure they were going to actually install the batteries. We were not sure they were actually going to install the solar PV. We always pre-wire for solar panels, for battery backup, and for EV chargers in the garage. You have to do that. And the upcharge on that, that's just some conduit running around. It's, you know, under $1,000 to get it pre-wired. So, but that is the challenge, is kind of performance versus budget at different types of houses. This is a really interesting one because you want more people doing houses. I mean, we don't want to just do expensive ones, and we don't want to just wait for government programs to do affordable housing. These are the kind of houses that more and more people should be able to do.
Scott, I don't know if you had any addition to that question.
I was just going to say agreed, and honestly, not much more to add to what Nate said. I think Nate put it well. One of the analogies that I might be able to use that might resonate with the audience that we have here is following Tesla to an extent. Tesla didn't come out of the gate with the Model 3. Tesla came out of the gate years ago with the Model S, and it was a higher priced product built for it wasn't a Bentley, right, or a Bugatti, but it was certainly more expensive than a Chevy Volt. And so that's a little bit of what we have to do sometimes, is try more expensive technologies in higher design homes so we can understand the cost benefit trade-offs, understand what works, what can be tweaked and improved, and push that down into more attainable homes, eventually getting to the point where we're building affordable homes without subsidies, because the design becomes much more efficient. Or honestly, the overall lifetime cost, not just the first cost, becomes part of the calculation. So first cost versus total cost of ownership needs to get more into the industry as well.
Some questions here specifically, Nate, in comparing gas versus electric. And so specifically, did you consider in the cost trade-offs, the ability to potentially remove both the gas piping and the ducting? You talked about mini splits. I mean, was that considered in the factor of the higher cost for the heat pump systems? And then obviously you showed energy savings, which is great, but did you consider just total operation costs savings in heat pumps versus gas systems?
So we actually did some of the cost analysis here, Nate. Let me jump in and then you can provide a little bit more detail, because we broke this down line by line for the client to make sure we understood the cost trade-off to go 100% all electric here. And what we wound up looking at was about a $7,000 increase from the $7,000 net increase, taking into account the subtraction of the gas piping, the meter charge from the local gas utility to get set up for that, taking into account the ComEd credit that Nate was talking about during the presentation, but then also adding on the cost of the additional electric, potentially to go to 400 amp service, the additional electric piping that's necessary, the induction cooktop or range that would be there, plus the heat pump water heater that would be included. So overall, our estimate for this particular project was a $7,000 change to go all electric net when everything was pulled out of it, like you just said, Fred. Nate, anything to add to that one?
Yeah, so I did show on that EUI chart, it did have, I didn't talk about it, but it did have the energy savings. And, honestly, I don't really lose sleep over the energy savings or highlight it too much. The problem we have in Illinois is we have dirt cheap electricity, and that's really fun for my electric car, but it's a problem when we look at these cost analysis. And the thing of it is, it's not linear. We could change on a dime with the nuclear power that we have. It's subsidized nuclear power and it's cheap right now, but those plants were built in the early 70s with a 30-year life, and they keep getting extended. And we've already got one set up in Zion that's been, decommissioned or in the process of being decommissioned. And the other ones are going to slowly start doing that, and we're going to start to change our electric rates. So right now they're really cost effective, but if you look at the East Coast, they are literally 3 to 3.5 times per kilowatt what we are here. And that would be bad for some things, but boy, it would be very impressive for comparisons of homes like this. So I think that's a little bit of the future proofing, because I think that's probably, I don't know if we're going to go that expensive on electric. I hope that really we're going to start to see the wind power and commercial solar really being the source for electricity, and hopefully that stays affordable. But it's probably not going to stay as cheap as it currently is. I hope that answered that. But we do look at that. But when it's a good metric to look at. There's no question. But I don't want to not do electric. I think doing electric is the right thing for CO2 emissions. And that's really the goal, more so than saving, $30 here and there. $30 here and there, if we don't do what we need to do for CO2, isn't really going to matter.
And actually, real quick, there were some comments because we were bouncing between the ideal design and the current design. So I wanted to reiterate to everyone: this house does not have mini splits. It does have a ducted, high efficiency natural gas system. So I wanted to make sure I cleared that up. That's just sort of the standard design you use, Nate, and what the ideal design is, and that's what we were comparing. But before we wrap up, Scott, you were mentioning this Flipside townhomes study, these comparisons. I don't want to put you on the spot. You can say, let's talk later, but is that something we could, talk to you about later, maybe do a virtual tour of, or learn, share with our audience?
Yeah, most certainly. That particular project will be on this summer's Chicago Illinois Green Alliance, the Greenbelt Home Tour. So that tour is actually virtual now due to the COVID situation that we're in. So you can learn more about that tour. And that honestly is an ongoing research and development project for us. So we've got the first cost. So as I talked about just a few minutes ago, we know what it cost us to build each of those homes, from the conventionally stick frame to the panelized, from the zip wall to the tie-back, from fiberglass blown-in insulation to cellulose insulation. We did all of those different systems and all of those different materials and methods. And we also have different mechanical systems in each one of those homes. So those homes just sold and just have families moved into them as of about 3 months ago. So for us, that's a long-term project where we want to see the overall durability, the overall energy performance, and the overall client satisfaction of living in those homes. So would a webinar next month be productive? Probably not, but in 13 months after we've got a year of utility data, really to be able to compare air quality data, I think that would be awesome, because getting that out into the market would help not only us build better homes, but would help builders across the country and architects across the country build and design homes, at least with some more cost data in mind as to what a trade-off would be for price versus performance. Absolutely, Brett.
Great, yeah, we'll follow up with you in a year. But yeah, big plug for the Illinois Green Build Alliance's Chicago home tour, which now is going to be virtual. So we'll send out a link to that. Typically, Nate, you have projects on that every now and then. Brightleaf has projects on it all every now and then. Sounds like you all can join from the safety of your home, so we'll put that out there. And yeah, before we wrap up, just again, real excited to have you out. Thank you guys for your time. Scott, just real quick, where can people contact you to find out more information or get any other questions answered?
That would be straight to our website, just brightleafhomes.com. They will be able to get everything that we have about the homes that we have in progress, and then also the overall services that we offer, from new construction to renovations to real estate, to try and really sort of transition the market overall into a high-performance home building, home buying experience, not just building green homes. Great.
And Nate, where can people contact you or go to learn more?
Yeah, so our website is kipnisarch.net. I'm sorry, .com. Geez. So it's KIPNISARCH.com. And yeah, we're here in Evanston. We're also out in Boulder. If anyone's knowing anyone moving out there or are out there, happy to help.
Great. Well, Scott Sanders, Brightleaf Homes, Nathan Kipnis, Kipnis Architecture and Planning. Thank you so much for joining us here today. And we're going to wrap up now. And just quick public service announcement, if you don't have to go out, if you can stay at home, please stay at home. Please stay safe. And we can beat this thing. We can get through this. We want to see you all in person at a real tour someday. So take care, everyone. Have a great weekend. It's beautiful out there, hopefully. So thank you so much. Bye.